So next algorithm is your C-scan. So in C-scan we are servicing the request only in one direction. Then again we are going to the end and then starting in the same direction. So one direction only the scanning will be done in C-scan. That is a circular scan. Provides a more uniform wait time than scan. The head moves from one end of the disk to the other, servicing request as it goes. When it reaches the other end, however, it immediately returns to the beginning of the disk without servicing any request on the return trip. So it scans its service only in one direction. In return trip, it will be empty and it will go to the end of the disk, start of the disk or end of the disk. Trace the cylinder as a circular list that wraps around from last cylinder to the first one. So this is a C scan. So here it will scan in one direction only and it will go to the end. Then again from the end it will go to the next end and then again start with the first and then it will scan in one direction. So this is scanning in only one direction. We can go left or we can go right, but it will scan in one direction. So that is nothing but the C scan. Then C loop, it is a version of C scan, but it will not go to the end here. ARM only goes as far as the last request in the each direction, then the reverse direction immediately without first going to the way at the end of the disk. So it will not go to the end of the disk. End location, it will not go to the end location. So C loop, so you can see here it will not go to the end, which happens in a circular scan. So C loop start with 53 and then go in a one direction only, but it will not go to the end of the disk. So last is your 183. So from last again it will go to the initial smallest one. So that is a 14. So it will go to the last and again it will scan in the same direction. So this is nothing but your C loop. Then selecting the disk scheduling. So how to select the disk scheduling algorithm? So SSTF is a common and has a natural appeal. Scan and C-scan perform better for systems that place a heavy load on the disk. Performance depends on the number and types of the request. Request for disk service can be influenced by the file allocation method. Disk scheduling algorithm should be written as a separate module of operating system, allowing it to be replaced with the different algorithms if necessary. Either SSTF or loop is reasonable choice for default algorithm. Then the next point is your RAID model. So RAID is a multiple disk drive, provides reliability and redundancy. So the full form of RAID is a redundant array of independent disks. RAID is arranged in 6 different levels. Several improvements in the disk use techniques involve the use of multiple disks working cooperatively. Disk stripping use a group of disks as one storage unit. RAID scheme improves performance and improves the reliability of storage system by storing redundant data. So in any disk fails, so we can have the backup. So redundant data will be available. So we are creating the mirroring or shadowing keeps duplicate of each disk. So if any fault occur in a disk, we can get the second disk. So block interleave parity uses much less redundancy. So this is a RAID level. So in level 0, non-redundant stripping is done. RAID 1, we are doing the mirror of this port. See, here are the mirror disks. In RAID 2, memory style error correcting ports are available. Then RAID level 3, bit interleave parity is there. So this is a bit interleave parity. Then RAID 4, block interleave parity. And then in RAID 5, block interleave distributed parity. So each and every one will have the parity. And RAID 6, we are having the P plus Q redundancy. So each will have the double. So we are creating the duplicate one. So RAID levels. So it is a strip 0, strip 2, 1, 2, and 3. So strip 4, 5, 6, 7. So this is we are creating the each and every strip for this one. So this is RAD level 0. Then RAD level 1, we are creating a duplicate of all these 4 here. Then RAD, this is the architecture of RAD levels of bit parity. So RAD level 0 to 3 backups and parity drives are shared. So we are creating a parity for each strip. Then this is a RAD level 3rd parity bit is there. It will consist all of this information. Then RAD level 4 for parity and here we are creating the P and Q. So RAD level 3 to 5 backups and parity drives are shared. Then RAD level 6 and 7. So in 6 P and Q are redundancy and RAD 7 is heterogeneous disk array. Then disk attachment. Disk may be attached one of the two ways. First one is host attached via an IO port, and second one is a network attached via a network connection. So network attached storage using NAS. So this is a network attached storage. Then we are connecting the LAN WAN, and this will be a client. So this is nothing but a network attached storage. So that is a RAD level, then data server and tape library. So this is your LAN data processing center, web content server provider, and you are using the SAN storage area network here for connection of RAD and server. So we look various disk scheduling methods to optimize secondary storage access. We also study the basic principles of RAD. Then we have studied the network and storage access are the two recent advantages in secondary storage. So already, as we know, one more, that is nothing but your look is there. So look works same as your scan, but in look it will not go to the end direction. So in the loop, so what happens in scan, it is going to the end here, but in the loop it will not go to the end, it will go to the 14. From 14 again it will start here, it will fall 65, 67, 98, 122, 124 and 183. So in loop it will not go to the end. So that is difference between scan and loop. So these are the 6 algorithms. First one is your FCFS, second one is SSTF, that is the shortest seek time first. Third one is your scan, fourth one is C-scan, fifth one is look, and last one is a C-look. So these are the 6 disk scheduling algorithms. Now if you go for IO buffering, so there are 4 types of IO buffering. So already we have finished here also. What do you mean by IO buffering? So IO buffering, as the IO devices are slower than the memory, for that purpose we are using the IO buffering. So in that there are 4 types of IO buffering. First one is a no buffering, in which no buffer will be used. Directly there will be from input to the processor and execution by the OS. The second one is a single buffering, in which one buffer will be there. Third one is a double buffering, and last one is a circular buffering.